Okay, welcome to Lesson A2, Pythagorean Theorem and its Converse. I'm going to apologize that I do not have my inner pad. I'm doing this from home and left that at school, so I will not be able to write on the slides, but I will talk you through it, and also I can use my mouse. The Pythagorean Theorem was named after Pythagoras. The Pythagorean Theorem was named after Pythagoras because he's the one who provided a proof. He's not really the one who discovered it. The Pythagorean theorem is on your reference sheet. Most of you have seen it before. It's a squared plus b squared equals c squared. Now, a and b stand for the two legs. C is your hypotenuse. It's always going to be the longest side of the triangle. It's going to always be opposite the right angle. Find the length of the hypotenuse. So all you're doing is plugging the Pythagorean theorem. This is x. It is the hypotenuse, so it's going to go in for c. When you work out the Pythagorean theorem, you are going to square first. So this would give you 18 squared. This would give you 13 squared. Then you're going to add them. Once you add, your last step is to take square root. It's like you're taking the square root of both sides, because the square root of something squared cancel each other out. They're inverse operations. By the way, in order to get credit for your notes, you need to write down all of the examples. Of course, you can write down other things you think are important, but make sure you're copying down the examples. If you're printing out the PowerPoint, you still need to do the examples by hand. Okay, example 2, this time we're looking for a leg. So, when you plug into the Pythagorean theorem, and it doesn't matter which one that you plug in the legs for, A or B, what matters is that you plug in 26 for C because it's the hypotenuse. So, this works a little bit different. You're going to start by squaring your numbers. You're then going to subtract 196 from both sides. The last step, after you get x squared equals 480, you're going to take the square root of both sides, so that cancels out the x squared, and you get x is the square root of 480, and on your calculator this is approximately 21.9. Okay, how to use the converse. When you're using the converse of the Pythagorean theorem, you are actually plugging into the theorem and asking yourself, is this a right triangle? We do not go by looks. Notice there's no right angle here. I know it looks right, but 89 degrees also looks pretty right. You're going to plug these numbers into the theorem. What's important is that your longest side, your biggest number, always goes in for C. The other two, it does not matter, A and B. So, 10 squared plus 13 squared equals 25 squared. That one has to be C. When you go to work this out, you get two different numbers on both sides. Well, that means if it does not work in the Pythagorean theorem, it is not a right triangle. So the answer is no. Okay, example 3. Again, we're going to ask ourselves, is this a right triangle? We're going to plug these numbers into the Pythagorean theorem. This is going to be going in for C. I'm not going by looks, I'm just going by what's the largest number. This time, the answer comes out to 625 equals 625. If you get the same thing on both sides of your equation, then the answer is yes. Okay, so if a squared plus b squared equals c squared is a right triangle, what happens if it's not equal? Well, if you have your two legs, the square of your two legs is less than the square of your hypotenuse, it's going to be an obtuse triangle. That means that angle is going to be greater than 90. And if you have your two squares of your legs greater than c squared, then it's going to be an acute triangle. In other words, that angle would be less than 90 degrees. You might want to write this down. Okay, Pythagorean triples are sets of whole numbers, okay, so not decimals, not fractions, whole numbers that satisfy the Pythagorean theorem. They are called triples. Now there's different kinds of triples which we'll talk about at a different time. these are some common Pythagorean triples. In other words, if you plug these numbers into the Pythagorean theorem, it will work. So I've listed them all, so the last number is the highest, which would be your hypotenuse, but it doesn't always have to be listed in that order. But when you're plugging into the theorem, you're going to plug in for the highest. So 3 squared is 9, plus 4 squared is 16. That should equal 5 squared is 25. Well, 9 plus 16 equals 25. This is why it's called a triple, because these three whole numbers work in the theorem. And the same is true for all of these. You might want to print out this slide or copy it into your notes so you can start recognizing the triples. It will help you work faster when we are continuing with right triangles. Okay, using your Pythagorean theorem, you're going to be seeing word problems. Now, for these particular examples, I have drawn the picture, but many times I do not draw the picture. So you're going to have to draw the picture for yourself after you read it. It says the foot of a ladder is placed 6 feet from the base. Okay, the ladder is 16 feet tall, so that's how long the ladder is. How up high does the wall does it reach? So we're looking for this. Here's your right triangle, okay, because the wall and the ground are going to form a right angle. So 16 is your hypotenuse. So it's just using the Pythagorean theorem, it's just giving it to you in the form of a word problem. Okay, so it's going to come out to approximately 14.8. All right, this one's a little different because they're giving you the length of the diagonal and they're asking you for the width and length of this high-def monitor. The key is here that the monitor is a square. So that means all sides are going to have the same length. So regardless of whether you use this upper right triangle or this lower right triangle, they're going to be the same because all sides are x. So instead of plugging in A or B, we're going to call them both x. And you can call them both A, you can call them whatever you want, but they're going to be the same variable. You can't solve for two variables at once. But how you work this out algebraically, you're going to put your like terms together. So x squared plus x squared is 2x squared. And I just squared 52. You're then going to divide both sides by 2. Once you get down to this point, your last step is to take square root on your calculator. Okay, this one kind of works the same way. Got my animations off a little bit. Need to fix that. Except this time we gave you the sides of the square because a baseball diamond is a square. And we're asking you to find the hypotenuse. So you're going to plug in 90 for both legs. And you are going to go ahead and square first, then add, and your last step is to take square root. Now, if you play baseball, you might know how far it is from home plate to second base. All right, your last example is asking what is the distance from one corner of the box to the opposite corner. Now, this is what we're talking about. Okay, so I think we're going to go over, let me go back for a second. I think we're going to go over this one in class. I'm going to have you write it down, but this one's a little bit more detailed, and I want you to see if you can find a shortcut. But what I did here, my drawing's off a little bit, got to move it, is I used this bottom right triangle. Imagine this triangle on the bottom if I draw a diagonal going from this corner to this corner. And then I went ahead and used the triangle that's standing up. Okay? I'll show you this tomorrow. We're going to go ahead and skip this one for right now, but go ahead and at least write it down so it'll only take us a minute. Okay, here's your extra credit problem. You might want to pause it because I'm going to go to the last slide to keep this short. And that's your assignment. You will have time to work in class tomorrow because there will be no lesson. I'll just go over that one problem and see if you have any questions. And both assignments for 8.1 and 8.2 will be due Monday. Okay, good night.